So, hey folks, I got a question for you. And in this video, we're going to talk about what does it mean to find the distance between a line and a point, or a point and a line. So here is a line. I'm pointing at it right now. Okay, my mouse cursor is kind of going over it. And just to be sure, it's this guy right here. There's a name for this line. It's called line AB. We could also call it AD or AE or DB. There's a number of names, but let's call this line AB. And what we'd like to know is we'd like to know what is the distance between line AB and point C. And what I'd like you to do is I'd like you to hit pause on the video and take a look at this picture, and I'd like you to think about it for a minute. If this was a multiple choice situation and we had to choose, and let's say one of these guys was, well, certainly possibly one of these guys, one of these numbers here is the option for what the distance is, but maybe it's not, maybe it's something else. So I guess my question for you is if you had to make a guess as to what the distance was from this line to this point, would it be one of these numbers or would it be something else? Hit pause, study it for a minute, and think to yourself which one of these numbers would be the best answer for what is the distance between line AB and point C. Or are none of them a correct answer, and would you prefer to choose something else? Okay, I'm assuming that you paused the video and that you reflected for a minute and you thought either the distance is 4.7 or 4.3 or 5.4. Maybe you think that the distance from E to C is a better guess than the distance from A to C. Who knows? Maybe you thought it was something entirely different than any of these. Who knows? Maybe you might have even thought, I don't even know. I don't even want to make a guess. But what I would like to do is tell you what I think the distance is. Okay? If we are asked what is the distance between this line AB and this point C, we will say that the distance is the length of a line that is perpendicular to this line and goes through this point. So that's one of the reasons why we study the whole idea of perpendicular to a line and goes through a point. It's because if we have a line and we have a point and we want to know the distance between the two, we got to do the distance where the distance line has to be perpendicular to AB, perpendicular to this guy, and go through this point. Now, if you're just going to eyeball it and just guess, I'd like you to hit pause and take a guess as to which one of these lines would be the best estimate for that. Take a moment, pause the video, see if you can guess which line would be the best line to use for distance. Okay, I'm hopeful that you paused the video, and now your choice would have been either line AC or line DC or EC or BC. Which did you choose? I'm hopeful that you chose line DC. Now, at this point, you don't know for sure that this is perpendicular, but it sure looks way more perpendicular than AC or EC or BC. And if that's the case, we would then say the distance is 4.3. Now, now the other thing is when you're given problems like this, you may or may not be given these distances or these lengths. So we need to have a way to calculate the distance between point D and point C. And it turns out we do have a way. It's called the distance formula. And one of the things that I've shared with my students is that to me, the distance formula, all it is Pythagorean theorem. But it is Pythagorean theorem. And I told you before you're going to need to know Pythagorean theorem, and here it is. We need it again. So what we could do is take the coordinates for point D and the coordinates for point C, and we could use Pythagorean theorem. Now some of you are saying, well, Pythagorean theorem on what? You know, so you know, well, look, here's a leg, here's a hypotenuse, right? Well, no, that's not how we do Pythagorean theorem when we're dealing with points in space. When we're dealing with points in space, no matter where the 2 points are, no matter how funky the 2 points look, the way that we make the right triangle is we take the 2 points no matter where they are, and we either go horizontally from the one point and then vertically down to the other, or horizontally from the bottom point and then vertically up to the other. That's how we make our right triangle when we're trying to use Pythagorean theorem to find the distance between 2 points. And that is true for any 2 points on the coordinate plane. Doesn't matter if they're here and here. Doesn't matter if they're here and here. No matter where the 2 points are, we should be able to have a vertical line that comes down and then a horizontal line that goes across, and we should be able to make a right triangle. And the same is true for point C and point D. We should be able to make a line that comes down from C and then goes over to point D, and then whatever the length is of this leg down here, we will square it, and then we will take whatever the height is of this leg here, we will square that, and we'll add them together and take the square root, and that should get us this hypotenuse CD. Now, I'm going to see what I can do here. I know C is definitely at -3, 3. It's at x is -3, y is 3. So we know that point. This one's a little trickier because it looks like it's at a fraction. So I'm going to go to the calculator to get the exact points, and what we see is for C -3, 3, for D it's -0.8, -0.7. So let's try to do the math with that using Pythagorean theorem. Here we go. So here are the 2 points in space. Here's -3, 3, and here's -0.8, -0.7, and I want to point out to you that we don't even have a coordinate plane anymore. We only have 2 dots. We don't have all the other lines to confuse us, but I'm going to show you how to use Pythagorean theorem to figure out this distance between the 2. What we're going to do is we're going to make a vertical line that goes down like this, and we're going to make a horizontal line that connects across like this, and then we'll make a diagonal line between the 2 points. The diagonal line between the 2 points is the hypotenuse, and whatever length that is, that'll be the distance. We're going to call it little c for now, because when we use Pythagorean theorem, the c is usually the hypotenuse. And just to remind you guys, it's, well, hold on. Hit pause, see if you remember what Pythagorean theorem is. Okay, here we go. I'm hopeful that you remember. It's c squared equals a squared plus b squared. If that's the case, we should be able to find the length. Now, the trick is, how do we find a and b? And by the way, it doesn't matter whether we call this side a or b or this side a or b. Doesn't matter. I'm just going to call this guy a for now and this guy b, and my decision was random. Doesn't matter. But how can I figure out what a is? Well, a is the distance between this point and this point, but only vertically. So all I'm concerned about is that this guy is at 3, y equals 3, and this guy is at y equals -0.7. So if I want to figure out what a is, here's how I'm going to do the math. It's going to be that whatever a is, it's going to have to be 3, which is this, minus whatever this is, minus -0.7. Now, another way to look at it is that apparently, if this is y equals 3 and this is -0.7, it looks to me like the x-axis must be somewhere around here, right? Because this guy's negative and this guy's positive. So, in a way, what I'm doing is I'm adding up the 3 above the x-axis plus the 0.7 below the x-axis, and that's why it turns out to be 3 minus -0.7. So let's go ahead and do this math, and it goes like this. It's going to turn into 3 plus 0.7, and then yay, that is so easy. That's just 3.7. Okay, next we're going to go ahead and try to figure out what b is, and let's give it a shot. B is equal to, now this time, B is this length here. It's this x value, -3, and it goes all the way to the x equals -0.8. So from this x to this x, whatever they are, x1, x2, who cares? We know that we got to go from x is -3 to -0.8. Now, in order to find that distance, we can just subtract the one from the other. And some of you folks, well, some of you may recall, well, let me say this. The distance is going to be positive. We can subtract either one from either one. It doesn't matter. Whatever result we get, we're going to make it positive. So in this case, I'm going to try, I guess I'll try to do it the technical way, since the correct way, since I'm the math teacher. I'll take the bigger number, which is -0.8, and I'll subtract the smaller number, which is -3. So I go -0.8 minus -3, and that will get me -0.8 plus 3. And so that will get me a distance of 2.2. All right. So anyways, now I have B is 2.2. Now I'll go ahead and write it in there. And I have A is 3.7. And I should be able to use Pythagorean Theorem to find C. And if you recall from our drawing, it looked like it was 4.3. Let's see what it turns out to be. This will be, let's try this. This will be C squared equals 3.7 squared plus 2.2 squared. And then C equals the square root of those two. So I'll go ahead and do square root of whatever those are. Let's do a little bit of math. Okay, so 3.7 squared plus 2.2 squared is 18.53. And we'll take the square root of both sides, and when we do, this C squared becomes, well, maybe I should show you just to be safe. On the C squared side, we're taking the square root. When we're all done, we should have C equals whatever the square root is. And by the way, it's not really equal, it's approximately. This is not the same as congruent. This, when we have the two squiggly lines, it means approximately. It's approximately 4.3. You can try it yourself on your own calculator. So what we discover is the distance between these 2 points is 4.3. And I'd like to remind you what we were trying to do from the beginning is we were trying to figure out what happens. Let's see if I can show you. We were trying to figure out if we knew that the distance between line AB and C was the distance of the length of the segment CD. We could find that out by using the distance formula or Pythagorean theorem to figure out the distance between D and C. And again, when we see D and C, we can make that into a right triangle, not by using anything that's on the screen that we see, but simply by just recognizing that between any 2 points on the coordinate plane, we can make a right triangle. All right. That took a little longer than I'd hoped, but I hope it's useful to you.